The 1984 Yamaha RZ350 looked like a regular two-stroke. It wasn't. It was the first of its kind to run emissions gear, carry onboard electronics, and pack race-inspired geometry, all without anyone really noticing. What Yamaha hid in this machine changed the way two-strokes were built. These are the 10 unknown shocking secrets about the RZ350 you've never heard of. And by the end of this video, you'll see this bike in a completely different light. Number 10, first street bike with catalytic converters. Most riders never notice it. Some still do not believe it. But the 1984 Yamaha RZ350 holds a record that no other street bike can claim. It was the first production motorcycle sold in the United States with factory-installed catalytic converters. Not a retrofit, not a concept. Full-on emissions hardware built directly into the mufflers. And the wild part? It was on a two-stroke. That decision tells you exactly where Yamaha's priorities were in the early 1980s. Emissions pressure was rising fast. The Environmental Protection Agency was tightening the screws, and two-strokes, famous for their blue smoke and raw combustion, were firmly in the crosshairs. Most manufacturers played it safe and backed off, but Yamaha doubled down. The RZ350 came equipped with two catalytic converters, one inside each expansion chamber. These weren't visible or advertised. They sat tucked away, burning off unburned fuel as the exhaust moved through. That kind of technology on a high-revving two-stroke was unheard of at the time. But Yamaha didn't stop there. Hidden behind the left side panel was a temperature monitoring system. A small thermocouple tracked converter heat, and if things climbed too high, around the breaking point for the catalyst, a light on the dash warned the rider to ease off. Melted cores meant serious repair bills. So in a sense, this two-stroke came with built-in self-preservation. Why go to all this trouble? Because Yamaha needed a loophole. In the United States, emissions rules allowed limited sales of two-strokes, as long as their overall pollution output was offset across the full lineup. The RZ350's clean tailpipe gave Yamaha the numbers they needed to legally keep it on showroom floors. No other company managed to pull that off. The emissions hardware wasn't there for fun. It was Yamaha's ticket to sell a two-stroke road bike. When the world was shifting toward four strokes, they were threading a needle, squeezing this machine into compliance without stripping away its core identity. Of course, not everyone appreciated it. Many riders yanked the converters out, swapped exhausts, or rerouted things entirely. But from the factory, the RZ350 was a two-stroke built not just for speed, but survival. It is easy to look at this bike and assume it was built for chaos. But under the noise and the paint was a carefully calculated response to a changing world. Number 9, fuel filler restrictor to block leaded gas. Some design choices are bold, others are just smart. And then there are those decisions you barely notice, until you realize they were years ahead of their time. The fuel filler on the 1984 Yamaha RZ350 is one of those. Tucked under the gas cap was a small metal ring with a very specific job. It was not there for looks or cost-cutting. It was there to stop you from making a big mistake, specifically from pumping leaded gas into a bike that could not afford it. Here is why that mattered. The RZ350 was the first street-legal motorcycle in the United States to run catalytic converters. These converters were critical to the bike's ability to pass emissions tests and stay on sale in a tightening market. But they had one serious weakness: lead. Even small amounts of leaded fuel could coat the catalytic core, permanently disabling it in just a few tanks. And back in 1984, leaded gasoline was still widely available. Yamaha knew riders might not always pay attention at the pump, so they built a safeguard right into the bike. The fuel filler restrictor was a narrow ring pressed into the filler neck. It reduced the opening so that only the smaller unleaded gas nozzles would fit. The standard leaded nozzles used at the time were larger in diameter, typically around 1 inch, compared to unleaded, which measured about 13/16 of an inch. If you tried to insert a leaded nozzle, it just would not fit. Simple, mechanical, and effective. It was not a feature most people noticed. The restrictor sat just inside the cap, out of sight unless you were looking for it. But its purpose was very clear: keep the emissions gear safe, keep the engine legal, and most of all, keep Yamaha out of trouble with the Environmental Protection Agency. Because if a catalytic converter failed due to leaded fuel, it meant not just performance loss, but non-compliance. That could trigger fines or worse, loss of certification. There was no dashboard warning light for the restrictor. No sticker explaining why it was there. Just a narrow hole and a design choice Yamaha hoped would quietly do its job. And for the most part, it did. But riders being riders, some found ways around it. Aftermarket tanks, modified caps, or even simply removing the insert altogether. Most did not realize that doing so could destroy the converters in a matter of weeks. From a technical standpoint, the restrictor did not affect performance. It did not limit flow rate or change the fuel path, but it did represent a shift in thinking. Yamaha was designing not just for speed and control, but for compatibility with a changing fuel infrastructure, a motorcycle that could no longer tolerate what had been normal for decades. Looking back, that little ring was more than just a spacer. It was a quiet marker of a turning point, a time when two-strokes were adapting to survive, and in the case of the RZ350, doing it with just enough engineering to keep you out of trouble without ever saying a word. Think you've seen everything the RZ350 had to offer? We're just getting started. The next few secrets are even deeper. Stick around, smash that like button, and subscribe for the full story behind this two-stroke legend. Number 8. Hidden Air Injection Reed System for clean two-stroke emissions. There are some tricks engineers hide so well, you would never spot them unless the bodywork came off. And the 1984 Yamaha RZ350 had one of those tricks hiding in plain sight. It was called the air injection system, and it quietly helped this two-stroke meet emissions rules without anyone ever realizing it was there. Now most people think of two-strokes as dirty, oil-burning machines with a signature blue haze trailing behind. And in most cases, that was true. But Yamaha knew that if the RZ350 was going to survive in the United States market, it needed to clean up its act. Catalytic converters helped, but they were only part of the equation. To make them work effectively, the engine needed more oxygen in the exhaust stream. And that is where the air injection system came in. Mounted inside the left side bodywork, Yamaha installed a small, unassuming air filter connected to a pair of rubber hoses. These led to reed valves tucked near the exhaust ports, just downstream from the cylinders. The system worked on pressure pulses. When exhaust gases passed through, they created a low-pressure zone that pulled in a small amount of fresh air through the reeds and into the header. That extra oxygen helped the catalytic converters burn off unburned hydrocarbons more completely. It was passive, mechanical, and totally maintenance-free. No pumps, no electronics. Just clever use of existing engine behavior to reduce emissions without robbing power. And since the air was injected after combustion, it did not affect the fuel-air mixture inside the cylinders. The engine still made around 45 horsepower and torque, came in at roughly 30 pound-feet at 7,000 revolutions per minute. Riders got the performance they expected, and the EPA got lower emissions numbers. Everybody won. What makes this system especially interesting is how hidden it was. Yamaha did not advertise it. There were no markings, no decals, and no mention in the sales brochures. Even the service manuals barely explained its function. Most owners had no idea it existed unless they took the fairing off and started tracing hoses. But that low-profile approach was part of Yamaha's emissions strategy. Do the work, meet the rules, and let the bike speak for itself. In warmer states like California, where emissions enforcement was strict, this system played a major role in keeping the bike street legal. Combined with the catalytic converters and fuel filler restrictor, it formed a complete emissions package for a machine that, on paper, should not have passed inspection at all. The air injection system on the RZ350 was not flashy, it was not visible, and it did not make the bike any faster. But it did something just as important. It kept the two-stroke dream alive, one quiet breath of fresh air at a time. Number 7. Perimeter-style frame was a first for Yamaha. There is a reason the 1984 Yamaha RZ350 felt sharper than most of its two-stroke rivals, and it had nothing to do with horsepower. What made this bike stand out on the road, and more importantly, in the corners, was its frame. Not just how it was built, but how it was laid out. This was the first Yamaha street motorcycle to feature a perimeter-style frame, a design that would later define the look and handling of modern sport bikes. Most bikes at the time used what's called a spine or cradle frame. A single top tube or double tubes would run under or over the engine, forming the backbone of the bike. It was strong, familiar, and easy to manufacture, but Yamaha decided to break from tradition. With the RZ350, they introduced a perimeter-style frame, where the main frame rails wrapped around the engine and connected at the steering head and swing arm pivot. The idea was simple: reduce flex and improve rigidity by routing structural elements along the shortest and most direct path. The result was a bike that handled with precision. The frame was made from rectangular section steel tubing, offering more torsional strength than traditional round tube designs of the same weight. This meant the chassis resisted twisting under load, giving the rider better feedback during hard cornering or braking. It also lowered the bike's center of gravity, which helped with balance and stability at speed. At a glance, it did not look revolutionary. The frame blended into the bodywork, and to the untrained eye, it just looked clean and compact. But under that simplicity was real engineering. Yamaha had been developing perimeter frames in racing, and this was their first attempt to bring that concept to the street. The total wheelbase measured about 54.5 inches, and the overall weight came in at approximately 371 pounds dry. That put the RZ350 right in the sweet spot for flickability and responsiveness without feeling nervous or unstable. One key benefit of the perimeter frame was how well it worked with the engine layout. The RZ used a parallel twin two-stroke, and the frame design allowed Yamaha to keep the engine tightly packed while still providing enough space for cooling airflow and component access. It also let them mount the fuel tank lower, which improved weight distribution and rider ergonomics. This layout would become common later on, especially with aluminum perimeter frames in sport bikes from the late 1980s and early 1990s. But in 1984, it was rare to see a frame this advanced on a mid-weight road bike. Yamaha did not make a big deal about it in marketing, but those who rode the RZ knew it felt different. Stiffer, more planted, more confident at lean. The perimeter frame did not add horsepower. It did not make the bike louder or faster in a straight line, but it made everything the rider did feel better. And that is what set the RZ350 apart. Long before frame stiffness became a selling point, Yamaha had already figured it out and tucked it neatly under a two-stroke rocket with more going on than met the eye. Number 6. Balance pipe between reeds to smooth power delivery. Sometimes the smallest details make the biggest difference. And on the 1984 Yamaha RZ350, one of the most overlooked features is a short, narrow tube running between the intake boots. It is not flashy, it is not mechanical, and it does not move, but that little balance pipe plays a surprising role in how the engine feels from the saddle. It was Yamaha's quiet solution to an issue that plagued a lot of parallel twins, such as uneven throttle response at lower and mid-range speeds. Let's break it down. The RZ350 used a parallel twin two-stroke engine with individual reed valves, feeding each cylinder. Each carburetor handled its own intake charge, drawing fuel and air through separate intake tracks. That layout worked great at high revs, where both cylinders were breathing hard and in sync. But in the lower to mid-range zones, say around 3,000 to 5,000 revolutions per minute, there could be pressure imbalances between the two sides. That led to inconsistent response, with one cylinder occasionally pulling harder than the other. To solve this, Yamaha added a small balance tube that linked the two rubber intake boots just behind the carburetors and ahead of the reed valves. This pipe allowed pressure pulses from one cylinder to communicate with the other, evening out vacuum signals and helping synchronize the intake behavior across the rev range. It did not change peak power, it did not affect jetting, but it made throttle delivery smoother, especially in part throttle conditions, where crispness really matters. The result was a more predictable ride. When rolling on the throttle in second or third gear, the engine responded cleanly without hesitation. There was less bog, less flutter, and more consistent pull through the mid-range. That is exactly the zone where two strokes can feel rough or twitchy if intake pressures are not balanced. The balance pipe helped iron that out. From a design perspective, it was a clever move. The pipe itself was just a short section of rubber hose, a few inches long and less than half an inch in diameter. It cost almost nothing to implement, weighed next to nothing, and required zero maintenance. Yet it quietly improved rideability without adding complexity. And because the RZ350 was already pushing out around 45 horsepower at 9,000 revolutions per minute, Yamaha did not want to lose any of that hard-earned power to intake inconsistencies. And the engine's sweet spot lived right in that 5,000 to 8,000 revolutions per minute range. That is where the balance pipe earned its keep, smoothing out transitions and making the power band feel more usable in real-world riding. It is one of those details you would never spot unless you knew what to look for, and most riders did not. But the balance pipe is a perfect example of how Yamaha fine-tuned this bike far beyond the basics. It was not about adding flash, it was about making the engine feel right where it mattered most. So while everyone talks about the power valve and the catalytic converters, the real secret might just be that little tube between the carbs, quietly making every twist of the throttle feel just a bit more perfect. Number 5. Bizarre flat spot at 4,500 RPM. You twist the throttle, the revs climb, and just as you expect the rush to build, nothing. The bike hesitates. Not long, not loud, just a weird pause like it skipped a beat. No warning, no noise. just a sudden drop in urgency, right around 4,500 revolutions per minute. And if you have ever ridden a 1984 Yamaha RZ350, you know exactly what that feels like. This wasn't a misfire or a tuning issue. It was built in, a strange, brief plateau buried inside an otherwise sharp and lively power band. Some called it a flat spot, others called it a hiccup. But everyone who noticed it came away with the same question: what just happened? The answer lies in the bike's early electronic exhaust control system, Yamaha's newly developed power valve, better known as YPVS. It was one of the most advanced features on any two-stroke street bike at the time, and it worked by adjusting the exhaust port timing based on engine speed. The idea was simple: open up high for power, stay low for torque. But in the real world, things didn't always line up perfectly. At 4,500 revolutions per minute, the YPVS was mid-shift, not fully open, not fully closed. Meanwhile, the rest of the engine's systems, fuel delivery, spark timing, intake resonance, were also in the middle of their transitions. The result was a brief moment where everything seemed out of sync. The cylinders breathed just a little unevenly. The combustion timing was not quite ideal, and the power curve flattened for a split second. Not enough to stall, but enough to notice. Some riders tried to fix it. Tuners would swap in different jetting or tweak the servo control box to shift the valve's engagement point. But even then, it never totally disappeared. Yamaha did revise the system slightly in later models, but on the original 1984 version, it was just part of the deal. What makes it so interesting is how riders adapted. You could feel it coming. That tiny pause trained your wrist. It taught you to ride the bike with more feel, more rhythm, and then, just past the dip, it exploded to life again. That contrast made the experience more memorable, more dynamic. It wasn't always smooth, but it was always engaging. Yamaha never officially explained the dip, and they certainly never advertised it. But in a way, that flat spot became one of the most honest parts of the bike. It wasn't perfect, and it didn't try to be. It was a two-stroke built during a time of change, riding the edge between analog simplicity and digital control. So, if you ever feel that strange moment around 4,500 revolutions per minute, just wait. The delay won't last. The RZ350 may hesitate for a breath, but when it exhales, it does so with all the force a two-stroke can give, and that is what makes it unforgettable. Number 4. Autolube oil injection, routed through carbs. You know a bike means business when you never have to premix the gas. The 1984 Yamaha RZ350 was one of those machines that let you skip the mess without sacrificing performance. But what most people don't realize is just how clever its oiling system actually was. Yamaha's Autolube setup did more than just save you a trip to the measuring cup. It routed oil with precision right where it was needed and did it through a path few riders ever noticed. Let's start with the basics. The RZ350 was a two-stroke, which meant it needed oil in the combustion chamber to lubricate the piston and crankshaft. Unlike many earlier bikes, which required pre-mixed gas and oil in the fuel tank, the RZ used a separate oil reservoir and an engine-driven pump to inject oil automatically. That was the Autolube system, and it had already proven itself on smaller Yamaha models. But the RZ took it a step further. Instead of dumping oil directly into the crankcase or relying on splash lubrication, Yamaha routed the oil through small, dedicated lines straight into the carburetors, more specifically into the throttle slide housings. This meant that as you opened the throttle, the oil mixed with the incoming air-fuel charge at the precise point of entry, ensuring a consistent blend across both cylinders. It was clean, efficient, and smarter than most riders ever realized. The oil pump itself was mechanically driven off the right side of the crankshaft and adjusted flow rate based on throttle position and engine speed. That variable delivery was crucial. At idle or cruising speeds, the pump metered out just enough oil to prevent fouling. But when you twisted the throttle and the revs climbed, the flow increased to match. This helped maintain ideal lubrication while cutting down on smoke and wasted oil. Two things two-stroke riders were all too familiar with. What made this design even more interesting was how well it played with the rest of the engine. The oil lines feeding the carbs were incredibly thin, about 1/8 of an inch in diameter, and routed so neatly that most owners never even saw them unless they removed the tank and airbox. But those little tubes were doing a big job, keeping the top end alive at 9,000 revolutions per minute without over-oiling at stoplights. Yamaha even thought about safety. If the oil pump failed or the reservoir ran dry, the engine would quickly show signs, such as poor running, excess heat, and eventually seizure. But the system was known for being reliable. As long as riders remembered to keep the oil tank topped off, the The Autolube worked in the background without fuss, and because the injection was tied to throttle position, it delivered oil with far more precision than any premix could. The result was a bike that ran clean, pulled hard, and left your hands free of oil stains at the gas station. No bottles to carry, no mixing ratios to calculate. Just fill the tank with gas, check the oil sight glass, and ride. It was one of the most rider-friendly features Yamaha could have added, and they executed it with surgical detail. Most people think of oil injection as just a convenience. On the RZ350, it was a finely tuned system built to match the performance of the engine it fed. Quiet, precise, and tucked behind the scenes. Just another reason this two-stroke stood out from the rest. Number 3. Rare. Early 1984. Kenny Roberts with offset filler. There's rare, and then there's factory-built and barely understood. The earliest batch of 1984 Yamaha RZ350s hit showrooms with something no other version ever had, in the form of a fuel filler that was off-center, a paint job straight from the racetrack, and a configuration that quietly disappeared within months. Most riders never noticed. Collectors never forgot. Before Yamaha settled on a standard tank design, the first run of RZ350s in the United States arrived in a bold yellow and black livery inspired by Kenny Roberts' Grand Prix race bikes. But this was more than just a tribute paint scheme. These early bikes were functionally different, and the most obvious giveaway was the fuel filler location, offset to the right side of the tank instead of centered. It was not a styling choice or a regional variation. It was how those tanks were designed from the start, whether it was for tooling simplicity, part carryover, or internal clearance. Yamaha never said. What we do know is that by mid-year, the filler moved to the center and the offset version was gone for good. That makes these early bikes incredibly rare and instantly recognizable to those who know what they are looking at. But the differences did not stop at the filler. The wheels on these first-run models came finished in semi-gloss black with subtle edge polishing. The decal layout on the tank and side covers was sharper and more defined than later versions. The seat stitching, front fender contours, and even some of the fastener choices around the bodywork had small differences. None of them flashy, but all of them specific to that first production group. What makes it even more interesting is how casually these bikes were released. Yamaha never marketed them as a special edition. No plaques, no serial tags, no announcement. They were just the first off the line. And because they were painted like Kenny Roberts race machines, many owners assumed that the color was the only thing that made them different. It was not. Estimates suggest fewer than 2,000 units in this exact spec reached American buyers. And that was before years of riding, repainting, and modification took their toll. Original examples with the offset tank, factory paint, and early production parts intact are now some of the most sought-after RZs on the collector market. Unrestored bikes with these features can fetch well over double the value of standard models in similar condition. For the average rider, these distinctions may seem small, but to those who know Yamaha history, they speak volumes. This was the moment the company was blending race heritage with street reality, navigating emissions rules, and trying to keep its performance edge without losing its identity. So the next time you see a yellow RZ350, do more than glance. Check the filler cap. Look at the wheels. Because if everything lines up, you're not just looking at a cool paint job. You're looking at a forgotten factory variation that came and went before anyone knew how special it was. Number 2. Built under emissions quotas, causing early US discontinuation. Some bikes are discontinued because they don't sell, others because they fall behind on tech. But the 1984 Yamaha RZ350 was forced off the market for a completely different reason. Emissions quotas. Not poor performance, not low demand, but strict legal limits on how many two-strokes could even exist. This wasn't a marketing decision. It was regulatory survival. Here's what most people never knew. In the early 1980s, the Environmental Protection Agency had begun cracking down on motorcycle emissions. Two-stroke engines, known for their high hydrocarbon output, were among the first to face pressure. Yamaha, determined to keep the RZ350 in its American lineup, made serious changes to meet the challenge: catalytic converters, air injection, and a fuel restrictor system. It all worked, but only just. Even with those updates, the RZ350 still emitted more pollutants than the growing fleet of four-stroke motorcycles Yamaha was producing. The EPA allowed it under a system called fleet averaging. This meant that Yamaha could sell a certain number of high-emission models, but only if they were balanced by lower emission units elsewhere in the lineup. Essentially, every RZ sold had to be offset by enough clean-running four-strokes to keep the total fleet within legal limits. However, there was a cap, a quota. Yamaha could only sell a limited number of RZ350s in the United States each year without exceeding its emissions allowance. And once that number was hit, sales had to stop. No matter how much demand there was or how many bikes were sitting at dealerships, the EPA line could not be crossed. That's why the RZ350 was sold in the United States for only 2 model years, 1984 and 1985. After that, it disappeared. Not because riders didn't want it. In fact, demand remained high. But continuing to sell the bike would have meant sacrificing emissions credits that Yamaha needed for its expanding lineup of four-stroke street and touring motorcycles. From a business standpoint, it simply wasn't worth the trade. The result was a bike that left the market at its peak. In many ways, it had just hit its stride. Riders were getting used to the new tech. Aftermarket parts were starting to flow. Tuners were figuring out how to squeeze more out of the already potent engine. And then, just like that, it was gone. Very few bikes in Yamaha's history have had a run that short, and fewer still with that kind of impact. Today, the RZ350 holds a strange position in motorcycle history. It wasn't retired because it failed. It was retired because it worked too well for a system that didn't know what to do with it. Collectors and enthusiasts now see the limited run as part of the bike's appeal. The short production window, especially in the United States, makes every surviving model feel like it snuck through a closing door. A small rebellion that somehow got stamped and shipped before the rules caught up. And that's the strange legacy of the RZ350. It wasn't beaten by the market or the racetrack. It was boxed out by emissions math. A fast, sharp, two-stroke outlaw that played by the rules just long enough to make its mark, then vanished before anyone could stop it. Number 1, hidden wiring for YPVS power valve and basic computer control. It did not beep, flash, or display any fancy data, but behind the fairing of the 1984 Yamaha RZ350 sat one of the most important pieces of tech the company had ever fitted to a two-stroke street bike, a compact control box with a bundle of hidden wiring that ran Yamaha's new power valve system. Most riders never noticed it. Some still don't know it is there. But without that quiet little box, the RZ would not have been the same machine. Yamaha Power Valve System, or YPVS, was a game changer. It used a rotating valve in the exhaust port to adjust timing based on engine speed. At low revs, the valve stayed down, lowering the port height to improve torque. At higher revs, it rotated upward, raising the port height and unlocking more top-end power. That part is well known. What's less talked about is how the system was controlled and how far ahead Yamaha was in slipping it into a street bike. Inside the front cowl, mounted just behind the headlight, was a small sealed electronic control unit. It received input from a tachometer signal and sent commands to a servo motor mounted under the tank. That motor pulled cables connected to the power valve, opening or closing it based on engine speed. The threshold was programmed to activate near 6,000 revolutions per minute, transitioning the engine from low-end grunt to high-end scream in one smooth motion. All of this happened without buttons, screens, or menus, but it required wiring, lots of it. Tucked beneath the tank and running alongside the frame was a network of color-coded wires, wrapped tight and routed through dedicated clips. For a 1984 model, this kind of integration was incredibly advanced. It was not just a mechanical system. It was a basic computer, doing real-time adjustments to the engine while you rode. Yamaha never advertised it as computer-controlled, but that is exactly what it was. Not programmable, not digital in today's sense, but a solid-state unit making timed decisions with zero input from the rider. It worked quietly in the background, adjusting valve positions several times per second as the revs changed. The result was a seamless power delivery curve that felt unlike any two-stroke before it. Most riders only became aware of the system when it failed. If the servo motor burned out or the cable snapped, the valve would get stuck, usually in the low position. That meant great off-idle response, but the top end would fall flat. Others experienced the opposite, where the valve stuck open and made the bike hard to ride below 4,000 revolutions per minute. But when everything worked as intended, the system made the RZ feel like two engines in one. The hidden wiring and control unit were not glamorous. They were not even visible unless you stripped back the plastics. But they were critical. Without them, the RZ350 would have been just another quick two-stroke. With them, it became a multi-layered performance machine, capable of pulling from low revs and still screaming all the way to redline. That's what made it special. Not just how it looked or how it sounded, but how smart it was underneath. A quiet network of wires and circuits that turned a raw engine into something sharper, smoother, and years ahead of its time. And most people never saw it coming. Under all the noise, the RZ350 was smarter than anyone gave it credit for. If the RZ350 changed how you see two-strokes, hit like, subscribe, and let us know your favorite untold story in the comments.